NEC Article 300.4 F addresses the protection of conductors for American wire gauge or larger where they enter a cabinet, box enclosure, or raceway. The question at hand is whether panel boards fall under the category of cabinets, box enclosures, or raceways, thereby triggering the bushing requirement for the EMT connectors. Panel boards are distinct from cabinets, box enclosures, and raceways. They are classified as utilization equipment. This distinction is crucial in determining the applicability of NEC Article 300.4. Since the EMT connectors are entering a utilization equipment enclosure, namely the panel board can, the bushing requirement stipulated in NEC Article 300.4 F does not apply. The code specifically targets cabinets, box enclosures, or raceways, and panel boards as utilization equipment are excluded from this categorization. Therefore, in the scenario presented, bushings are not mandated on the EMT connectors within the panelboard cans. To elaborate, consider the function and purpose of each component. A cabinet serves as a general enclosure for electrical equipment, often providing protection from the environment and physical damage. Box enclosures are smaller, more localized enclosures typically used for housing wiring connections, devices, or components. Raceways, such as EMT conduits, are channels specifically designed to house and protect electrical conductors. Panel boards, on the other hand, function as distribution points for receiving power from a source and distributing it to various branch circuits. They contain overcurrent protective devices, such as circuit breakers, and are designed to facilitate the control and protection of electrical circuits. The NEC differentiates between these components based on their intended use and function. Article 100 defines a cabinet as an enclosure that is designed for surface mounting or recessing and is provided with a frame, mat, or trim in which a swinging door or doors are or can be hung. An enclosure is defined as the case or housing of apparatus, or the fence or wall surrounding an installation to prevent personnel from accidentally contacting energized parts or to protect the equipment from physical damage. A raceway is defined as an enclosed channel of metal or non-metallic materials designed expressly for holding wires, cables, or busbars, with additional functions as permitted in this code. Raceways include, but are not limited to, rigid metal conduit, intermediate metal conduit, electrical metallic tubing, rigid non-metallic conduit, flexible metal conduit, wireways, and busways. Panelboards are not explicitly defined in Article 100, but their function as distribution points with overcurrent protection places them firmly in the category of utilization equipment. This distinction is important for several reasons. Firstly, it ensures that the correct code requirements are applied to each component. Secondly, it reflects the different roles and responsibilities of each component in the overall electrical system. Thirdly, it promotes clarity and consistency in the interpretation and application of the NEC. In the specific scenario described, the two parallel 350 and cm feeders, two runs in 3.5-inch EMT conduits, supplying the three 600 amp breakers within the 1600 amp 480 volt switchgear cabinet feeding the three MLO panel boards, are governed by different code sections depending on the specific location and function of the wiring. The feeders entering the switchgear cabinet would be subject to the requirements of Article 300.4 F if they are for American wire gauge or larger. However, the EMT connectors entering the panelboard cans are not subject to this requirement because panelboards are considered utilization equipment, not cabinets, box enclosures, or raceways. To further clarify, consider the potential consequences of misinterpreting the code. If panel boards were erroneously classified as cabinets or box enclosures, bushings would be required on all EMT connectors entering the panel board cans, regardless of the conductor size. This would add unnecessary cost and complexity to the installation, without providing any significant benefit in terms of safety or performance. Conversely, if cabinets or box enclosures were erroneously classified as utilization equipment, bushings might be omitted where they are actually required, potentially leading to conductor damage and safety hazards. Therefore, it is essential to understand the precise definitions and distinctions provided by the NEC in order to ensure compliance and promote safe electrical practices. In summary, the answer is no, bushings are not required in the EMT connectors in the panelboard cans because panelboards are classified as utilization equipment, not cabinets, box enclosures, or raceways. This determination is based on the definitions and distinctions provided in the NEC and reflects the different roles and responsibilities of each component in the overall electrical system. When working with electrical installations, it is crucial to consult the NEC and other relevant standards to ensure compliance and promote safe practices. Always refer to the latest edition of the NEC and consult with a qualified electrical inspector or engineer if you have any questions or concerns. Furthermore, it's important to understand the broader context of conductor protection within electrical systems. While bushings may not be required in this specific instance, other forms of conductor protection may be necessary depending on the installation. For example, proper conductor support and securing methods are essential to prevent stress and strain on the conductors. Additionally, overcurrent protection devices, such as circuit breakers and fuses, are critical for protecting conductors from overload and short-circuit conditions. The size of the conductors is also important. In the scenario, the question states they are using 350 MCM feeders. It is important to make sure that the conductors are sized properly for the intended load and that the ampacity of the conductors is not exceeded. The NEC provides tables and guidelines for determining the appropriate conductor size for various applications. In addition to conductor protection, proper grounding and bonding are also essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, helping to trip over current protective devices and prevent electrical shock. Bonding ensures that all metal parts of the electrical system are electrically connected, minimizing the risk of voltage differences and electrical shock. Therefore, while the specific question focuses on a bushing requirement for EMT connectors, it is important to consider the broader context of conductor protection, grounding, and bonding when designing and installing electrical systems. A holistic approach to electrical safety is essential for ensuring the safety of people and property. Consider other sections of the NEC that may be relevant to the installation. For example, Article 314 addresses the requirements for outlet device, pull, and junction boxes, conduit bodies, fittings, and handheld enclosures. This article provides detailed requirements for the size, construction, and installation of these components. Article 344 covers the requirements for rigid metal conduit, while Article 358 covers the requirements for electrical metallic tubing. These articles provide specific guidelines for the use and installation of these raceway types. Article 408 addresses the requirements for switchboards, switchgear, and panelboards. This article provides detailed requirements for the construction, installation, and protection of these components. By consulting these and other relevant articles of the NEC, you can ensure that your electrical installations comply with all applicable requirements and promote safe electrical practices. Remember, the NEC is a comprehensive document that covers a wide range of electrical topics. It is essential to familiarize yourself with the code and consult it regularly when working with electrical systems. In the given scenario, the panel boards are supplied by two parallel 350 MCM feeders and two 3.5-inch EMT conduits. The NEC provides specific requirements for parallel conductors. Firstly, paragraph 310.10. H states that aluminum, copper-clad aluminum, or copper conductors of size 1/0 American wire gauge and larger shall be permitted to be run in parallel. Since the conductors are 350 MCM, this requirement is met. Secondly, paragraph 310.10. H2 states that all parallel conductors shall be the same length, conductor material, circular mill area, insulation type, and be terminated in the same manner. This ensures that the current is equally distributed among the parallel conductors. Thirdly, paragraph 310.10. H3 states that parallel conductors shall be adjusted for ampacity. Table 310.15. V3. I provides adjustment factors for more than 3 current carrying conductors in a raceway or cable. If the conductors are installed in a manner that requires adjustment factors, the ampacity of the conductors must be adjusted accordingly. In addition to these requirements, it is also important to consider the voltage drop of the parallel conductors. The voltage drop should be calculated to ensure that the voltage at the panelboards is within acceptable limits. The NEC provides guidelines for calculating voltage drop in Informational Note Number 1 of 210.19. A1 for branch circuits and Informational Note Number 1 of 215.2. A1 for feeders. By following these requirements, you can ensure that the parallel conductors are properly installed and that the panelboards receive adequate power. It is also worth noting that the NEC permits the use of equipment grounding conductors in parallel under certain conditions. Paragraph 250.122. F states that where parallel equipment grounding conductors are used, they shall be sized in accordance with Table 250.122 based on the size of the ungrounded conductors. The equipment grounding conductors shall also comply with the requirements of paragraph 310.10 H. In conclusion, when working with electrical installations, it is essential to consult the NEC and other relevant standards to ensure compliance and promote safe practices. The NEC provides detailed requirements for a wide range of electrical topics, including conductor protection, grounding, bonding, parallel conductors, and overcurrent protection. By following these requirements, you can help to ensure the safety of people and property. Always consult with a qualified electrical inspector or engineer if you have any questions or concerns. Furthermore, always refer to the latest edition of the NEC, as codes and standards are subject to change. The NEC is updated every 3 years, and it is important to stay current with the latest requirements. In addition to the NEC, other relevant standards may also apply to electrical installations. For example, the National Electrical Manufacturers Association, NEMA, publishes standards for electrical enclosures, raceways, and other electrical equipment. These standards provide detailed specifications for the construction, performance, and testing of these components. The Institute of Electrical and Electronics Engineers, IEE, also publishes standards for electrical systems, including power distribution, grounding, and surge protection. These standards provide guidance on the design, installation, and maintenance of electrical systems. By consulting these and other relevant standards, you can ensure that your electrical installations meet the highest standards of safety and performance.